Hello Pre-Calculus, this is a video on notes for 5.1, simplifying rational expressions. We're also going to look at multiplying and dividing rational expressions. The notes on here might look slightly different from your printed copy, but the examples should be the same. So Unit 5 is all about rational functions, but what is a rational function? A rational function has the form f of x equals p of x over q of x, where p and q are polynomials, and q cannot be equal to 0. So that means any equation that looks like this setup is rational, but you could also have something that looks like this. This would also be a rational function because this could be rewritten. We could change the 3 so that it has a denominator of q of x and combine everything into one big rational equation. The most basic rational equation is this one here in this graph, and it's 1 over x. We know that that's the parent function because we've studied parent functions before. So this is the most basic version, but rational functions can get a lot more complex. The other key part of the definition is that q of x cannot be 0, and that's because anything divided by 0, like 10 divided by 0, is undefined. So we can't have our equation, our function, be undefined. So we'll be looking for values that make the denominator 0 and excluding them from the domain. So today we're going to start with simplifying and then move to multiplication and division. So what are the key steps for simplifying rational expressions? The first one is to factor. So let's look at example 1 down here. This looks like we could simplify it right away using what we know about simplifying fractions and rules of exponents. But let's just think about it in terms of factoring first. Factors are just things that are being multiplied. So I could think of 36 as 6 times 6, and I know x cubed is x times x times x. So this expression has been factored now. And 42 I know is 6 times 7, and x squared is x times x. So this is just if we expand everything, we can see that our 6's cancel, and we have 2 sets of x's that cancel. So that leaves us with 6 over 7 and this x. So the simplified expression is 6x over 7. Now we also need to think about excluded values. What can x not be? And to figure out what x can't be, we have to think about setting our denominator equal to 0. So if I were to set 42x squared equal to 0, or say, oh, it can't be 0, I would then solve for x. So I'd divide both sides by 42, and I would get x squared cannot be 0, and that means that x cannot be 0. So my excluded value here would be x cannot be 0. So we can either call this an excluded value, and I'm just going to abbreviate an excluded value, or you can think of this as the domain. If this was a function, this is the x value that you cannot have in the domain. Okay, so let me clear that so I can give us a little more space. So the final simplified version there was 6x over 7, and x cannot be 0. So let's move to the next one, number 2. I'm going to look at it in a similar way again, except I'm going to chunk things. So I've got this 12 over 8 that can be simplified. Then I have an x squared over x, and I'm going to simplify that. And then I have y to the 7th over y to the 4th, and I'm going to simplify that. So 12 over 8 we know simplifies to 3 over 2, or negative 3 over 2, because I'm dividing out a 4. So if I divide 4, I get 3, divide by 4, I get 2. Then x squared over x leaves me with just x. And then x to the 7th over x to the 4th, this cancels and leaves me with a y to the 3rd. That's just basic rules of exponents. So now I've got y to the 3rd. So this is my simplified rational expression. But I also want to think about excluded values. For excluded values, we go back to the denominator, and we think about the factors. And I have essentially two basic factors here. I have 8x and I have y to the fourth. If I don't want my denominator to be 0, 8x can't be 0 and y to the fourth can't be 0. So I'm going to write 8x cannot be 0. I'm going to divide both sides by 8 and I get x cannot be 0. And then if I have y to the fourth equals 0, I could take the fourth root of y to the fourth and the fourth root of 0 and I would get y cannot be 0. So my two excluded values are x cannot be 0 and y cannot be 0. Okay, let's erase some of this to give us more room for the next problem. And those excluded values I'm just going to write up here. Y can't be 0 and x can't be 0. So that's for number 2. Okay, so for number 3, is this expression factored? No, we can't simplify unless our expression is factored. So that means we only have things that are being multiplied. So I need to factor this first. In the numerator, I can factor out a GCF of 2, leaving me with r minus 2. So 2 is a factor and r minus 2 is a factor. And in the denominator, I also have r minus 2. Well, now I have factors that cancel, which means that my simplified expression is just 2. So this original expression simplifies to 2. Okay, now I need to think about excluded values. My denominator cannot be 0 because I can't divide by 0. So I'm going to write r minus 2 cannot be equal to 0. If I add 2 to both sides, that means r cannot be 2. So that's my excluded value. Or if I was doing a domain, the domain could not include 2. Okay, let's go to our fourth example here. This one isn't factored at all. We're going to have to factor both the numerator and the denominator. And I would factor using a diamond. Let's see, so we've got negative 20 and 8. The two numbers would be 10 and negative 2. So I've got x plus 10 times x minus 2 in the numerator. And then I'm going to do the same for the denominator. I have a times c value of 10 and a b value of 11. So my two numbers are 10 and 1. So I get x plus 10 times x plus 1. Okay, so now I'm going to think about what cancels. Well, x plus 10 cancels with x plus 10, leaving me with x minus 2 over x plus 1. So this is my simplified rational expression. But now I need to think about what are my excluded values. And we said anytime we're thinking about excluded values, we need to look at the denominator. And we don't want to look at just the denominator of the simplified one, because this would tell us x can't be 1. But that's not all. We have to go back to the original or the first factored denominator to think about all the possible values that x cannot be. So looking at the original or looking at this original factored version, we should see we don't want this whole denominator to be equal to 1. So to find out when it is equal to 1, we're looking for the zeros. And we always look for zeros by setting the factors equal to 0. Or in this case, if you want to say that they can't be 0, that's fine, and then just solve like we normally would do. So x cannot be, that didn't turn out right. X cannot be negative 10, and x cannot be negative 1. These are the excluded values for this simplified expression. Okay, so I'm going to erase some of this work so that we have more room for the common errors that I usually see on quizzes and tests. Okay, so we said x cannot be negative 10 or negative 1. And actually, before we do the common error, I'm just going to go back to these instructions over here. We said step 3 is determine any excluded values by setting the denominator factors equal to 0 and solving. We should say do this with the original factored denominator. Not the simplified one. It's really hard to write neatly for these videos, so excuse the messy handwriting. So not the simplified denom. So you want to go back to the original and not just use the simplified denominator. Okay, so let's go back to this common error. All right, so often when students see an equation like this one, they see two y's and they say to themselves, oh, these y's cancel, and that just leaves me with y squared. But the math doesn't work like that. You can only cancel if things are factored. And here's an example of why. If I had 1 plus 1 over 1 plus 3, we all know that this is going to become 2 over 4, which is equal to 1/2. But if we use the logic from this error over here, it would imply that we could just cancel these ones, and that would give me 1/3. But we just proved that the fraction isn't equal to 1/3, it's equal to 1/2. So just canceling things when you have addition in the numerator and denominator does not work. We can't do this. So we're going to write no. We would have to factor first. So let's look at what that factorization would be. We'd factor the numerator and get y times y minus 1 over y. Then our factors cancel here, leaving us with y minus 1. This is the way you want to do it. So we can't cancel unless the expressions are factored. So we must factor first. Okay, there are now a bunch of practice problems which you can choose to do or not. I think it's good to practice at least a few of them. So I would pause the video now and try them on your own, and then restart the video to see the final answers. Okay, so the simplified version for number 3 is 4p over 7. That doesn't look like a 7. 7, with p not equal to 0. Number 4, the simplified version, is 4n over 3, with n not equal to 0. Number 5 is negative 5n over 2, with n not equal to 0. Then we have 1 over 2n squared, with n not equal to 0. For 7, we actually already did this in one of our examples, so I'm going to skip that. 8 is one that's frequently missed, so you definitely want to try this one on your own first. But here's how I would do it. I would leave this numerator as 45 and then change this to 10 times a minus 1. I then am going to look at this 45 over 10 and simplify that. And I can divide out 5, which leaves me with 9 and a 2. So the simplified version here is 9 over 2 times a minus 1. You could also change the denominator so that it's 2a minus 2, which is totally fine. And here, your a value cannot be 1. Okay, well, let's take a look at 9. The simplified version for that is 1 over 3x. And x cannot be 4 and 0. And this is an example of where you have to go back to the original denominator, the original factor denominator, and set the factors equal to 0 to find the excluded values. Because this final simplified one would imply that only 0 is excluded, but it's actually 0 and 4. Okay, and then this final one here simplifies to 5a minus 1 over 8. And what's the excluded value? There are no excluded values. So if we were finding domain, if this was a problem with an x value, we would say that it's all reals, all real numbers. Okay, at this point, I'm going to pause the video and move to a second video. So watch the second video to see multiplying rational expressions and dividing rational expressions.